going to talk about theoretical probability. I read a lot of your definitions, and I thought it was perfect. Can someone tell me what the unofficial definition of theoretical probability was? Yes, sir.
What is supposed to happen?
What's supposed to happen? What should happen? So go ahead and write down theoretical probability on your piece of paper. Theoretical probability is what should happen. That's why it's called theoretical. So theoretical probability is what should happen. I thought that was perfect, perfect, perfect. So what should happen? So what did the fraction look like for theoretical probability? Favorable over total. So favorable outcome over your total number of outcomes. So favorable over the total outcomes. You don't have to write down these problems. We're just going to do them together. And I'm going to link it to what we're doing today. Because we're basically doing theoretical probability today. But just one extra step. What is... So I'm just reading the question. What is the theoretical probability to spin and land on the color orange? Well, what would my favorable outcome be? Orange. How many ways are there to land on orange? 2 out of how many total possibilities? 6. You can reduce if you want to. You really don't have to because I want this in a percent. I want it rounded to the tens place, so one place after the decimal. So what is 2 over 6 as a percent? 33.3%. And that would be the answer. Number 2, what's the theoretical probability to spin and land on the color pink? Well, how many favorable outcomes are there to land on pink? 1 out of how many? 6. And 1 over 6 is? I want to say 16.7. Does anybody want to check that? Okay, 16.7. Perfect. The last question. This will be on the quiz and on the tests. I just made them printed them yesterday. If you spin the spinner 36 times, how many times would you predict to land on the color orange? Well, we just said we land on orange how much of the time? 2/6, which is what? The same as 1/3. So 1/3 of the time we land on orange. Sorry, wrong one. This one. 1/3 of the time we land on orange. So we would want to predict that we're going to land on orange 1/3 of 36. So how do you find 1/3 of 36? Yeah, so you can divide by 3, which is the same thing as multiplying times 1/3. So what would we get? 12. So you should bet 12 times that we would land on the color orange. Okay? Make sure that you don't answer as a percent. That was the number one mistake people made. But if I asked you how many times you said the word no today, if you said 1/5, doesn't really make any sense. Okay, so make sure you see how many times you're answering with a number. Then we're going to talk about experimental. So go ahead and write down experimental probability. So experimental. So theoretical is what should happen. What is the experimental probability?
What happened?
What actually happened. Yeah, what actually happened. And you're always going to see a chart, which would also be good information. So experimental is what actually happened, and you will see a chart, just like we have here. So experimental is what actually happened, and you will see a chart. What did the fraction look like? It looked a little different than theoretical. What went on top? It wasn't favorable. Yes. What do we call it when something happens that we want it to happen? A success over the number of trials. So successes over the total trial. So success over the total trial. So do we know how many times we tried spinning this spinner? How could we find it? Add them all up. What do we get for the total? Just going to write it over here. 70? Do we agree? Okay, 70. So that means for this fraction, when we do experimental probability, 70 is going to be on the bottom. What is the experimental probability to spin and land on the color orange? So how many times did we land on orange? 21. What does 21 over 70 become as a percent? It is 30%. So it's pretty close, actually, because we said it should land 33.3% of the time. They did 30%, so it's pretty close. A little less than what you would expect. What is the experimental probability to spin and land on the color pink? How many times did they successfully land on pink? 9 out of how many total trials? 70. So what's 9 divided by 70? Are you sure? 12.9. Yeah, I like the tens place, so we don't have to round up. We don't have to round down. All right, so that's experimental. I'm going to show you this example with what we're doing today in a hot minute. We're going to talk about independent versus dependent events. I want you to write down independent events. So independent events. On your homework, it's literally going to say, is this an independent event or a dependent event? If I said that I was independent, what does that mean? I'm on my own. I can stand alone. Okay? Independent events mean the first event does not affect the second event. I would write that. The first event does not affect the second event. So the first event does not affect the second event. First event does not affect the second event. So here's what that means. When you roll a dice, okay? Let's say I roll a 6-sided dice. What number do I roll? Pick one.
4.
That was a lot of numbers. 2. It was the closest person. 2. Okay? Let's say I roll a 2 first. I pick up the die and I decide to roll again. Is 2 not a possibility anymore? It still is. Rolling a 2 the first time doesn't affect what I roll the second time, correct? I independently roll and I roll again. The first one will not affect the second one. Dependent, you want to write down dependent, will be the opposite. So the first event does affect the second event. I'll show you an example. First event does affect the second event. So that means the second event is depending on the first event. Okay? So I have 4 cards. What are the odds I pick any 4 of them?
1.
What are the odds I pick any 1 of 4 of them? 1/4. Let's say I pick one and I don't put it back. Now I have my second event where I pick another card. Now what are the odds I pick any of them? 1/3. So picking my first card affects my second event. However, let's say I had 4. I picked one and then I put it back. So my second event, how many do I have? Still 4. Me putting it back makes that independent. But if I keep taking it out, whatever I take out affects my second event. Does that make sense? If you eat, let's say I had 10 apples. Okay, and one day I want a green apple. Okay, so let's say I had 10. I ate one of them. The next day, how many do I have to choose from? 9. Because I ate one. You ain't going to eat an apple twice. Right?
Right.
There's one problem on your homework. It talks about shirts. And I know some of us, probably boys more so, don't agree with this. But usually, most of the time, you don't wear the same shirt 2 days in a row. Am I right?
Right.
Yes.
Yes. Thank you. So your homework is going to say, you have, let's say you have 12 shirts to pick from. Monday you wear one. How many options do you have for Tuesday? 11, okay? Because that is dependent. Whatever shirt I wear Monday, I'm not wearing Tuesday. I pray that is the case here, okay? So we're going to choose. So somebody's going to pop up. We're going to ignore it for a second. We're going to choose whether these events are dependent or independent. We're still on our sheet of paper, just deciding. Spinning a spinner twice. So let's say I spin it once, I spin it a second time. It's going to be independent. 2 separate events. The first one does not affect the second one. So that would be independent. Choosing a person to be vice president and choosing a person to be president. Can someone be both? No. So let's say I have these 8 people to choose from. Okay? Let's say I choose Grace to be my vice president. That affects who's going to be my president, because can she be my president now?
No.
No. Okay, so who I pick first will change who I can pick second. That make sense? This one would be dependent, depending on who I picked first and then second. 3 and 4 you're going to see a lot, because I don't know if you've noticed yet. Probability, there are a lot of spinners, dice, and marbles. That just is what it is. Next year when you get his book, it's going to be the same thing. Spinners and marbles. Anyway, so let's say you had marbles in a bag. You take one out, and then it says replacing it. What does replacing it mean? Putting it back. Okay, so does the first event affect the second event? No. So that would be independent. But if you took it out and never put it back, that would be dependent. Because if you took out the green marble, the second event you can't pull out another green marble. Make sense? So, what you're going to do is we're going to go to 12.2 for now. You're going to put aside that paper. Take out 12.2. I want you to take out a highlighter. I hope I was recording this whole time, because I was. Okay. Sometimes hit pause and I don't realize it. I want you to highlight this phrase, and I'm going to explain it to you. It's going to ask you to find the probability of 2 events. So it'll say find the probability that I choose a green marble and find the probability that I choose a blue marble, or something like that. So what you're going to do, what does the letter P stand for here? Okay, so this says probability. So probability, I probably spelled that wrong, probability, whatever, you get it. Nope, you don't, I can't do it. Okay, we'll just do bub. So probability of event A, and then what do you think the other part means? Probability of event B, what's happening between them? Multiplied. So what you're going to do is you're going to find the probability of event A happening, find the probability of event B happening, and then you're going to multiply them together. Okay, let's do our first example. As part of the board game, you need to spin the spinner, which is divided into equal parts. Find the probability that you get a 5 on your first spin and a number greater than 3 on your second spin. So how many events do we have? How many events do we have? We have 2 events. We'll call the first one event A. What's event A? What do I want to get first? A 5. Here's the most common mistake. How many ways are there to spin a 5? 1 way to spin a 5. Out of how many total numbers? 8. It is not 5 eighths unless there are 5 number 5s. Okay? That's the number of times you can spin it. Event B, what does event B want me to find? A number greater than 3. So a number greater than 3. So that would be 4, 5, 6, 7, 8. How many of them are greater than 3? 5 out of 8. All right, then what did we say we do with these 2 events? Multiply them. So multiplying fractions is easier than you think. You multiply straight across. 1 times 5 is? 5. 8 times 8 is? All right, and then make it a percent. Decently small. 7.8%. Final answer. All right, we ready for the next one? Okay. Use the same spinner. Find the probability that you'll get an even number on your first spin and a number less than 3 on your second spin. So we need to do our first event. What do we want for event A? For it to be an even number, yes. So even number. So how many of them are even?
4.
4 of them. 4 of them are even out of how many numbers? 8. So 4 out of 8. You can reduce. I personally am not going to right now, but you can. You'll get the same exact answer. Well, I can. What does 4 over 8 reduce to? 1/2. So I'll drop it under. So technically that's 1/2, because the other one's going to reduce too. What is event B? What do I want to happen next? Less than 3. So how many of them are less than 3?
2.
2 of them out of 8 of them. What does 2 over 8 reduce to? 1/4. So the only perk to reducing is it's easier to do. 1 times 1 is 1, and then 2 times 4 is 8. So you'll get the same answer. It's just you can do it easier. What is it?
12.5%.
12.5%. All right, we flip. And I actually, no, we do this first. Bless you. So this one can be harder for some people. A bag contains 20 $1 bills and 5 $100 bills. So I want you to pause. How many total items do they have in the bag? 25 items. So the amount of money does not matter at all. It's literally, it could be like you saying, I have 20 red pieces of paper and I have 5 green pieces of paper. Like, it's just giving you a difference between the two papers. Okay? But there are 25 total items. Is everyone okay with 25? So what happens is you randomly draw a bill from the bag, set it aside, then randomly draw another bill from the bag. Find the probability that both events A and B will occur. So what phrase was especially important to us? Set it aside. What does set it aside tell me? It's not going back in the bag. So at first I have 25 things to choose from, right? I take one out. The next time I do something, how many do I have to choose from? 24. Okay, so set it aside means I'm not putting it back in the bag. So we're going to see, this is called a dependent probability, because whatever I pull out first will change what I pull out second. So for our first, how many total bills do we have? 25, so that goes on the bottom. Favorable would be the amount of $100 bills, because we're trying to pull out a $100 bill. Who wouldn't? So how many $100 bills are there? 5 of them. We can reduce this. It will be 1/5. So I'm going to put it at the bottom. So 1/5. This is just written in a different format. Event A and event B. Just different. Now we're going to find the probability of event B. How many now do we have to choose from?
4.
It'll be 4 $100 bills because we took one out already. And then how many total bills do we have? 24. We already took one out. So 4 because we took out a $100 bill. 24 because we already took out a $100 bill. So both of them will decrease. What is 1 over 24 reduced to? 1/6. So then we multiply straight across. 1 times 1 is 1, and then 5 times 6, 30. What does that make as a percent? 3.3%. The odds are not in your favor, my friends. Okay, so that is independent and dependent probability. So you'll flip to the next page, and you'll pause for a second. I'm just going to show you this. This is the type of problem you'll see. What is it's not on your page, what is the theoretical probability to spin the color orange first and the color green second? So to spin orange first, what are the odds? 2 out of 6. You can reduce it. I'm not going to right now. And then the second event is to spin green. So what are the odds for that? 1 out of 6. Multiply straight across. 2 times 1 is 2. And then 6 times 6. What is 2 over 36? Yes, but what does it make as a percent? 5 point. I think it's 5.6. Yeah. Because 5. But you're good. I appreciate you. Okay, so these are the type of problems you'll see on your quiz. Okay, you won't have one that says $100 bills and $200 bills. There's no such thing as that, but you know what I'm saying. They won't be that hard. It'll be like regular probability. All right, so a quality control inspector checks for defective parts. The table shows the results of the inspector's work. So, have you ever eaten M&Ms and had like a weird-looking M&M in there? Like a... None of you?
I'm a Skittle.
Okay, a Skittle, any food that like it's a bag of something and you have one wonky one that's like, how did you make the cut? Because what happens is, and the Skittle factory too, if you ever watch How It's Made, they have like a sifter for all the bad ones to fall through, and they keep all the good ones. See what I'm talking about?
Oh, yes.
I feel like you're being mean to me, but I don't know. I can't tell. Is he being mean to me? You still think so? Okay. All right. So basically, these things either pass or fail. Okay? If they fail, they fall through because they're too small. Things like that. So here's what the chart says: 5 of them passed, but they were defective. So they made the cut, but they actually weren't good. 208 of them passed, and they were not defective. So 208 of them, they passed and they were good. That was perfect. 24 of them failed that were defective. 9 of them failed that were actually good. That makes sense? So you're reading the pass, defective, pass, not effective. That's how you read a chart. What I want you to do with your highlighter, with your highlighter, whenever you read, find the probability that. That is like a, hey, I'm about to tell you what the total is. Right after it is always going to be the total. So a defective part, that is the total. I'll explain that. So just highlight it. That's where you find your total. So we're looking at the defective parts. Are the defective parts a column or a row? So columns are up and down, rows are left and right. What do you think? That's a row. How many total are defective? 29 are totally defective. How do you find 29? Add them together. It's 29 total that are defective. How many of them were defective and passed? Nope. 5. So defective total goes on the bottom. How many that were defective and passed goes on the top. Okay, so whenever it says that, whatever's right after it, that's all you're looking at. So a defective part, we're only looking at this row. We found the total of that row. And then how many passed in that row. What is 5 over 29 reduced to? Or percentage? 7 point what? 17.2. 17.2%. All right, second, find the probability that a non-defective part, so that's my total, so that a non-defective part passes. So let's find the total of non-defective first. How many total were not defective? 217. How many of the not defective passed? 208. What is 208 divided by 217? 95.9 is 0.9.
What? My bad.
Okay, so there's that. All right, so this one is harder for people to see because the defective, not defective, but this one is easier. At a school, all 9th and 10th graders, students are required to take either band or chorus. The table shows the enrollments. Find the probability that a 10th grade student is taking band. So if you look, 57 9th graders are taking band, 63 9th graders are taking chorus, 48 10th graders taking band, 77 10th graders taking chorus. So we're looking at this, finding the probability that a what? A 10th grade student. So I need the total of the 10th grade. Is that a row or a column?
A column.
It's a column. How many total 10th graders are there?
125.
125 total. So that's total 10th graders. All right, and all I want are how many 10th graders are taking band. 48. There's one step ahead of me. 48. So what's 48 divided by 125?
38.4%.
38.4%. Perfect. This leads us to the next one. So 12.3. So 12.3 is all about tables. So we just did one. We're going to actually be filling them in this section. So if you look, we have this lovely picture here. What do we call this? A Venn diagram. we're going to take information from the Venn diagram, answer our questions, and then we're going to fill in the table based on the Venn diagram. So we have a survey of 80 students. Some of them play an instrument. Some of them speak a foreign language. Some of them do both. Some of them do nothing. So we're going to find out. How many students play an instrument?
45.
It is not 25. It's going to be 25 plus 26.
41.
It is 41. Because you need the entire circle. The whole circle. So you would add those two together. How many of them speak a foreign language? It is going to be 46. What does the part in the middle represent? How many do both? So how many students play an instrument and they speak a foreign language? 16. How many students do not play an instrument and do not speak a foreign language? 9. 9. The 9 that's off there and doing nothing. They're just there. That's some of us in here. How many students play an instrument and do not speak a foreign language? So play an instrument only. What is it? 25. So basically we take this information and we fill in the chart. Some people like to use the questions. Some people just read it. So here's what we're going to do. I'm going to go straight across. How many of them play an instrument and speak a foreign language? 16. How many of them do not play an instrument, but they speak a foreign language? It is 30. So how many people total speak a foreign language? 46. Play an instrument, do not speak a foreign language? 25. This one's the fun one, some of us. Do not play an instrument and don't speak a foreign language. 9. All right, and then 25 plus 9 is? 34. How do we find the totals on the bottom? Add them up.
Add the columns.
So 16 and 25 make? 41. That's how we found it earlier. 30 and 9 make? 39. So what should this bottom corner be? 41 plus 39, which is? 80. It should also be 46 plus 34, which is still 80. Because how many students did we survey? 80. So everything should add up. It's kind of like a Sudoku puzzle where everything has to fit perfectly. The rows have to add up, and then the columns have to add up as well. Okay? We're going to fill in our own at the bottom. We will talk about this in a minute. In another survey similar to the one above, similar to the one we skipped, 106 juniors and 114 seniors responded. Of those, 42 juniors and 77 seniors plan on attending. Organize these results in a two-way table. So where do we think we're going to put 106? Yeah, total juniors. So 106. All right, then we have total seniors too, right? Total seniors. So how many total kids do we have?
220.
It's a lot. All right, we keep reading. Of those, 42 juniors and 77 seniors plan on attending. So where am I going to put 42? Juniors that are attending, top left. And then I want to combine, or I want to put in 77. There's seniors that are attending. So 77. This will be enough information to find the remaining. So what is the total of those who are attending? 119, because you can add them together. If there are 106 total juniors, and you already have 42 of them, you're going to subtract. So what's 106 minus 42? 64. Same thing with seniors. We know there are 114 total. 77 of them are going. So subtract 36. And then you can add up, or is 36? 37. Because it's 101. It's okay. And then 119 and 101 make 220. And all across add up as well. Good? I believe we do one more together. No? Yeah, we're just doing the top one together. We'll actually finish these notes tomorrow. the rest of them. All right, number 1. So this is what your homework problems look like. Your homework is a worksheet, and I'll show you that. And then 2 problems from the textbook. They would be like this. I'm just asking you to fill in all of the missing numbers. That's all you're doing. So where you want to start is the most information. I would say this corner, bottom right, is the most information we have. If there are 130 total and 60 took the bus, how many total walked? 70. Because 130 minus 60 is 70. I'm also going to do it this way. You'll see why it makes a really easy number. I have 130 total. 58 were on time. How many of them were tardy? 72. Here's why I did that. Now I know 72 were tardy. 22 of them walked. How many of them took the bus? 50. You don't have to do it this way. You can do it many different ways. This is just easy. 50 of them were tardy that took the bus. How many of them were on time and took the bus? 10 of them. And then there are a couple ways to do this, but 58 total, 10 of them took the bus, so how many of them walked? 48. You could have done that many, many ways. I just like to do it the easiest and keep going. All right, so there's that. From here, we are going to start on our homework. That's it. Oh, it's going to pop up.